Next we are analyzing the portal frame by Canis method, which is having different column heights. That is, frame is unsymmetrical. So in this case, you can see that the AB is 4 meters and CD is 6 meters and the beam is of 6 meters. Here we can see that the moment of inertia is I, 2I and 2I. Okay, and it is applied with the sway load as well of 40 kilonewtons. It is lateral load of 40 kilonewtons is acting and 20 kilonewton per meter UDL is acting. So, as we know, the piston moments are for AB, BA, CD, DC are zeros, and that is minus MBC, minus MFBC and plus MFBC is equal to WL square by 12, that is 20 into 6 square by 12, it is 60 kilonewtons. After calculating fixed end moments, next we'll go for calculating the rotation factors. So with respect to joint B, we have BA and BC, and with respect to joint C, we have CB and CD. The two joints, we are considering those two joints, and remember BA 4EI by L and BC 4E into 2I by 6, that is 4 by 3A. So in this way, we'll calculate the rotation factors, and CB also the same, that is CB is equals to 4EI into 2I by 6, that is equals to 4 by 3 EI, and CD is equals to 4EI, CD is equals to 4EI into 2I by 6, that is 4 by 3 EI. So now the rotation factors are minus 1 by 2, 4 by 3 EI by 8 by 3 EI, that is equals to 0.25. And for CD it is minus 1 by 2 into 4 by 3 EI, which is this value, by 8 by 3 EI, that is equal to minus 0.25. After calculating the rotation contributions, next we are supposed to calculate displacement factor. So here the displacement factor formulas are varied, that is minus 3 by 2 into CPQ Q into K by sigma CPQ square into K. How do we find this C value, sir? CAB. Here in the column we are taking a common column, as we have discussed earlier itself, HR1 and this is HR2. So we are taking the common factor as the least one, that is HR1. So this formula is, that is equals to HR1 by HR1, and whereas that is AB, the ratio factor is taken as HR1, so the column factor is HR1, and whereas CD, the column factor is 6, that is HR2 1 by HR2. Okay, so here it is 4 by 6, that is 2 by 3 is equals to 0.67. Now when we go for calculating the displacement factors, just a moment. Yeah. When we calculate displacement factor, as it is a single story, the members are AB and DC, that is K is equals to 4EI by L, as this column is having 4 meters of height and this column is having 6 meters of height, that is DC is 4 into EI. I is also, it is varying, that is 2I, so that value we are taking over here. 4EI into 2I by 6, that is 4 by 3 EI. So the CP value is, as we have calculated earlier, that we are representing here. So sigma CP square into K is 1 is the value of CP, that is 1 square into EI into plus 0.67 square into 4 by 3 EI, that is equals to 1.89 So minus 3 by 2 into 1 into A by 1.89 A is equals to 0.79. So minus 3 by 2 into 4 by 3 into. So the displacement factor is minus 3 by 2 into CPQ K by sigma CPQ square into K. So that is equals to minus 3 by 2 into Cp is 1 into K is A by sigma Cp square into K, that is 1.89 A. Then the value is 0.79. Next, when you go for this value, is minus 3 by 2 into 4 by 3 EI into Cp is 0.67 to 1.89 into E, that is 0.70. After that, we will calculate the story moment, that is SR HR by 3. As we have taken HR1 as the ratio factor, we are considering the HR as 4, that is 40 into 4 by 3, it is 53.33 kilonewton meter. Okay. Then after that, resultant moments are the joint B, we have 0 minus 60, that is minus 60. Joint C, it is 60 plus 0. As we have calculated here, fixed end moments. Here BA is 0 and BC is minus 60. And CB is 60 and CD is 0. Okay. So this is MF BA plus MF BC and MF CB plus MF CD. Okay. So that is minus 60 and 60. So when we go for the frame, we are supposed to draw this frame. At each and every joint, we are supposed to represent this box. In the middle, we are supposed to give the resultant moments, whatever we have calculated here, and then the rotation factors. And these boxes in red color represents the displacement factors, what we have calculated here, and the rotation factors we have calculated here. These values we are representing over here. Next, in the first cycle, as we know that we are supposed to go with the same process, that is rotation factor into resultant moments plus far end contribution plus displacement factor. So displacement contributions. As in first cycle, we know that the displacement contributions and far ends will be 0 for AB and CB, BC. So that is minus 0.21 into minus 60 is equals to 12.86, and for CB it is 0.28 into minus 60 equals 16.8. But when we go for M dash CB, it is equals to minus 0.25 into plus 60 plus 16.8. It is this value we are representing here, plus 0 is equals to minus 19.2. Here in the frame, if you see, it is 0.21 into minus 60, plus here the value is 0 and initially it is 0. So we are taking directly minus 16 to 0.21 minus of. Next, when you go for M dash CB, that is, this is joint C and this is B, this is A and this is D. So CB, if you go on, so for CB, we'll take the value minus 0.25 into 60 plus 16.8. Okay. Plus displacement contributions are 0. That is why we will be taking as 0. That is minus 0.25 into 60 plus 16.8 is minus 19.2. Next, M dash CD is equals to minus 0.25 into 60 plus 16.8 plus 0, it is 19.2. Next, M star AB, that is displacement contributions, is equals to minus 0.79 into 12.6 plus 0 minus 19.2 plus 0 plus 53.33. That is 53.33 plus 12.6 minus 19.2. This equals minus 36.91. And DC is the rotation displacement factor, count factor is 0.70. That is equals to 53.33. The same it is existing, 53.33 plus 12.6 minus 19.2. It is minus 32.71. Next, similarly, we'll go for the second cycle. Similarly, we'll go for the second cycle. That is m dash BA is equals to minus 0.21 into minus 60 minus 19.2 is the value what we have got here, minus 36.91 is with respect to this value, is equals to 24.38. Next, 0.28 into minus 60 minus 19.2 minus 36.91, same, is equals to 30.58. Next, these values we will be representing over here. Okay. Next, m dash CB is equals to minus 0.25, 60 plus 32.51. This value we are representing here. That is minus 32.71, this value. Okay. Is equal to minus 14.95. Next, m dash CD is equals to minus 0.25, 60 plus 32.15 into same 32.71, that is minus 14.95. As this same will have the same values. Next, m star AB, that is the displacement contribution, is equals to minus 0.79, 53.33 plus 24.38. This 24.38 we have got from here, and 14.95 we have got from here. Okay, so 49.58, and here minus 0.70 into 53.33 plus 24.38 minus 14.95 is minus 43.93. Similarly, we'll go on with the third cycle. The values are 26.95, 34.86, minus 12.73 and 52.74. The same values we will be representing here, minus 26.15, 34.86, minus 12.7 and 12.73, and minus 46.72 and 52.73. Okay. So after that, fourth cycle will go on. When you go with respect to the third cycle and fourth cycles, the values are near about 52.73 and 52.73 and 53.28, 26.15, 26.34, 34.86, 34.16, 35.6, 12.73, 12.1, 12.73, 12.1, and 46.7, 47. So here the values are near about, hence we'll take these values as the final ones. Okay, these values we will be taking out for calculating the final moments. That is, final moments is equals to MAB plus, as we have seen at the starting itself, MFAB, MFBA, MFCB and MFCD at 0. So the formula is fixed end moment plus 2 into near end contribution plus far end contribution plus displacement contribution. So here the values are as follows. MAB is equals to 0.0 plus 2 into 0 as here the values are 0 and the foreign contribution is 26.34. So the displacement contribution is minus 53.38. The same we have to present 26.34 minus 53.38, that is minus 27.04. And BA is 0 plus 2 into 26.34 plus 0 minus 53.38. It is equal to minus 0.7. CB is equal to minus 60 plus 2 into 35.12 minus 0.1 plus 0. Here the CB values is, as we have known, CB and BC we having fixed end moments. So we are considering those fixed end moments, and the foreign contributions are, year end contribution is 35.1 and foreign contribution is minus 12.1. So here displacement contributions are zeros. That is minus 60 plus 2 into 35.12 plus minus 12.1 plus 0. It is 1.86, and CB is 70.31, CD is 71.4, and here also you can see that joints B and joint C are having near about values. Okay, so with this we'll end the Canis method analysis with respect to SVIL with same heights and different heights in columns. Thank you.